All right, let's go ahead and get started. I want to introduce myself. My name is Erik Gross. I'll be your instructor tonight, and I've been a computer programmer for well, honestly, since I was around 11 years old. But as most of my adult life, I'm also a Navy veteran. I was a nuclear reactor operator and electronics technician in the Navy, which is also where I discovered that I like to teach technical subjects. And I'm also the co-founder of the Tech Academy, which is the school that puts these free classes on. Thank you, Avnish. Appreciate it. Yeah, I did 6 years in the Navy, and I'm very thankful for the education they gave me. And even though it's been a long time since I got out, it's a very, very good thing. All right. So a little bit in terms of basic guidelines for the class. We have an assistant, Gracie, who you'll see in the chat. And she's there to monitor the chat, answer questions. We do ask that you be nice. She'll remove problematic students because these classes are for the people that are like super interested in wanting to be here and learn. And on that subject, this is an introductory class, but there will be points where you'll run into challenges. And part of the learning process is working through those challenges. So we try to make it as confrontable and easy to get through as possible, but don't be afraid to ask for help. I try to watch the chat all throughout the class, and Gracie monitors the chat. We'll give you whatever help we can give you. One big point on that is that when we do get to the point in the class where we're actually writing computer programming code, like typing in the instructions, please make sure you type the code exactly as it's written. The reason for this is that a misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized can result in errors in your code. So try to type exactly what I type. That's for later on when we're actually typing code. And then a couple other things. Please try to make sure you're in a distraction-free environment, right? There's a lot to get through, and if you have a distracted environment with noise and chaos, I just want you to be able to focus on the class, and I don't want to lose you while we're teaching. That said, if you fall behind, like if we're typing in the code and you fall behind, don't leave, stick around. You can and listen because you can still learn a lot, even if you don't end up being able to type in all the code. I also want to address one question right at the top because it gets asked a lot, which people ask, is this recorded? Can we see the recording afterwards? And the answer is yes and yes. You'll get, the full video will be uploaded to YouTube either by the end of the day today or tomorrow. We'll give you links to all of that at the end of the class. You'll also get the full code to the Connect 4 game at the end. You'll be able to play the game. You can have that, okay? So we've already covered a lot of this. If you haven't dropped into chat and let us know where you're joining us from, please do so. Just love to hear from you in chat. Let us know where you are in the world. Seattle. Awesome. I was stationed in Bremerton, right across the water from Seattle. Welcome, Jake. Fort Lauderdale. Very cool. I lived down near there a while. I've moved and traveled and lived in a lot of places. All right. So let's do a short explanation of the Tech Academy. This is the agenda. We'll have a short introduction to the Tech Academy. We'll write code, right? And teach along the way, which is hopefully why you're here. I try to answer questions as we're going through, but if I miss anything, we'll have a brief Q&A session after we write code. And then we'll go over some information about our boot camps. And there is a free gift at the end for you, so please stick around until then. Whole class should take about an hour and a half. All right, so a quick introduction to the Tech Academy. We deliver coding boot camps. If you're not familiar, coding boot camps are intensive technology programs that are designed to prepare people for entry-level positions in tech. They typically last anywhere between 3 and 6 months, depending upon where you go. They focus on practical modern skills. Boot camps have only been around for about 12 years. They're a relatively new development in the technology industry. That said, at the Tech Academy, we've been delivering thorough, budget-friendly, flexible, trusted coding boot camps for over 11 years. Like we started right at the beginning of this whole movement, which I'm pretty happy about. It was really exciting in the early days. The training certification programs we have are cost-effective, They're self-paced, they're fully online, they're tailored for beginners, people that have no prior technical or coding knowledge. They cover really in-demand skills, stuff the tech industry wants. They're endorsed by really stellar online reviews, and they're really flexible. They're designed to fit around your personal schedule and to prepare you for a technology career with a really well-rounded toolkit. Nationwide, the price of boot camps in America, at least, is around $13,500 on average. Ours are under the national average. In fact, we even have boot camps that start as low as $59.80. And finally, I want to wrap this section of the presentation up with just our mission statement. Why we're here. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's why we're here. Our product is you working in tech. So let's go ahead and get into the class here. I want to start with defining some pretty important terms. The first one is program. If you're not yet familiar with this, a program is just a series of written instructions that you can enter into a computer that will make the computer do things. You've used programs a lot. Like you probably use word processing programs or games or spreadsheet programs. What we're talking about here is you being the one that creates those programs, that enters those instructions in to make the computer do stuff. And those instructions are written in what's called a programming language, which, much like other written languages, is just an organized set of words and symbols and phrases that let you communicate with the computer and tell the computer what to do. This is how we make computer programs. Coding is the action of entering those instructions in, of writing a program. You say, I'm coding, and the instructions you enter in are called code. Again, really basic terms, but I want to make sure that they're fully understood. And finally, we better talk about Python, because this is what the class focuses on today. Python is a very popular computer programming language, been around for over 35 years. And there's a couple things about it that I like, especially when you're first learning about computer programming. One is that it's created in such a way that when you read it, it resembles common English, and you can usually, without too much trouble, follow along and in general tell what the program is doing pretty easily in Python. The other thing I like about it is that Python is an incredibly versatile programming language. There's all kinds of different programs you can make with Python, from apps, websites, games, productivity applications. All sorts of different programs can be made with Python. So it's pretty powerful. Now, we're going to move on here for a second. Let me get some water. And I want to just tell you my personal opinion about the next thing we're going to cover. And as soon as we're done with this next slide, we're going to start writing some code. But on this next slide is arguably the most valuable data that we will go over the whole night. And it has to do with what are the 5 fundamental or basic elements of any computer program. What are those things that you absolutely need in any program? And in fact, there's nothing else inside a computer program than these 5 things. So let's talk about the first of these 5 things. It's called an entrance point. I know it might sound relatively straightforward. This is just what's the first instruction in the program. But there's value in knowing the first instruction in a program. First, there's value to the computer that your program is running on. When you're on your computer and you start a program, like you double click on the icon or whatever else you do, you start the program. Obviously, there's a first instruction that has to run inside that program, and then the second one and the third one and so on. But something really important happens inside the computer when that first instruction of your program is run. What happens is this. Inside your computer are physical devices where data is stored. More precisely, there's physical devices called memory devices where the computer stores information that's going to be used by your program. And so when you start your program, what the computer does the computer that your program is on, what the computer does is it reserves a big chunk of that available space in which to store data and marks it off as belonging to your program and your program alone. And that way, other programs that are running on the computer can't change the data inside your area where you're storing data and mess up your program. Now, there's a lot of technical, nerdy terms we could use to describe that. They honestly aren't all that important yet. What is important is to know that when you start a program, your computer is going to start to manage some of those memory device areas where we store data. Now, the other thing that's valuable about knowing that there's a first instruction to every program is something that helps you, not the computer. And it helps you like this. I just actually had this happen the other day on a new project I was working on. Let's say that you break into technology and you join a programming team, a software development team, and that team is responsible for maintaining an established computer program. Let's say it's a really large computer program, lots of moving parts, lots of code. And one of the first things you're going to want to do is try to understand not just what this computer program does when it's running and you're interacting with it, but more importantly, how does the code work? All the instructions that are written down, how do I understand how the program works? And when you're trying to do that, one of the most valuable things you can do is find in the program that first instruction. When you turn on that program, when you tell it to run, what's the very first thing that happens? And having found that, you can follow through and look at the second thing and the third thing and the fourth and so on. And it's one of the smartest ways to start to understand a computer program that you didn't write. So, enough about the entrance point. It's one of the most important parts of a computer program. Now let's move on to element number 2. They're called variables. Now, variables, just like it says on the slide, it's just data that your computer program keeps track of. But more importantly, it's data that can change. I'll give you an example. If you're playing a game, and it's a game where you can score points, you're going to want a variable for the player to hold how many points do they have, because that could change from second to second, right? So variables are unique named pieces of data. We'll call it that. And it's unique named pieces of data that can change why your program runs. And we're going to be using those in our code tonight. The next fundamental element of any computer program is what we call control and branching. Control and branching is a system in your program where you can control the ability of your program to make decisions. More precisely, you can have elements in your program where the program is given a piece of data and asked to make a decision about it. Is it true or is it false? If it's true, your program will do one course of action. If it's false, your program will do another course of action. Let's say there's a program that analyzed, an image of someone's driver's license and determined whether or not they were allowed to buy alcohol. That's a yes or no, true or false, cut and dry decision. I'm sure you can imagine that your program is going to behave differently based on that decision. So we have to have a mechanism in our computer programs for controlling this. For one, making the decision, and two, defining the different courses of actions that could happen. We call those branches. And again, you're going to build these in our work tonight. Without control and branching, a program has a very limited value to human beings. We need to tell our computer systems what the criteria are to make a decision and what to do based on the result of that decision. And that makes a valuable program. The fourth fundamental element of any computer program is what we call subprograms. And there's a very brief description on the slide there, programs within programs. I'll tell you specifically what we mean. If you can get the idea that a program is that first instruction, and then the second, and the third, and the fourth, and so on, and the computer just starts at the top and starts going through all these instructions. Now, Imagine that you're writing one of these programs and it's quite large. And you find as you're writing it that there's a specific exact set of instructions that you end up doing over and over again, many different times in your program. Maybe it's a set of instructions for taking a first name and a last name and combining them into a friendly format instead of having two different pieces of data, first name and last name. And you find yourself doing that over and over and over again, and it's the same exact instructions every time. Well, there's a lot of problems with that, not the least of which is it's very easy to make a mistake when you're typing the same thing over and over again. Secondly, if you want to change the way those instructions work, you have to go back to every single place in your program that you did that series of instructions, and you have to change it in all those locations. And this isn't a made up thing. This is actually what computer programmers were struggling with in the very early days of computers in the 1950s and 60s. And then some bright person or persons came up with the idea, well, hey, listen, if there's this, say, set of 5 instructions that we keep doing the exact same thing over and over again in a given program, why don't we take those 5 identical instructions and set them off to the side and kind of like put them in a box and then give a name to that box. We'll call that box a sub-program. And then when we're building out our program, our main program, every time we need those 5 instructions to happen, instead of writing out all 5, we'll write one instruction. And it'll say, go do that sub-program, and when you're done, come back where you left off. That's the concept of a sub-program. They're very valuable. And again, we're going to build those tonight so you can see what it looks like. And again, without subprograms, your computer programs are very hard to manage. And finally, the last fundamental element of any computer program is an exit point. There needs to be some final instruction that informs the computer that your program is running on. There needs to be some final instruction that informs the computer, hey, this program's over. It's no longer running. And it's valuable for a number of reasons, and you would learn all the details on that in our boot camps. But I'll give you the first and most important one. When the program is no longer running, and you inform the computer about that the program is no longer running, now that computer goes to all of that memory device area, the area to store information that was reserved for your program, and it unreserves it. It frees it up so that other programs can use it. And it's actually really important because there's only a finite amount of space on the memory devices in your computer. Sometimes it's a small amount, sometimes it's a large amount. You've heard this term RAM. It stands for Random Access Memory, and it refers to those devices I'm talking about that store information. And there's only so many of them in your computer, and when they're all filled up, you got nowhere else you can store information. So when your program stops running, we want to tell the computer, hey, you can free up that space in those memory devices. All right, so there's the 5 elements of a computer program. Again, these are the only things you'll ever find in a computer program. And so knowing that makes it a bit easier to confront learning a programming language. And we're going to use these 5 things as we look at how Python works. All right, now let's go ahead and get to coding. A couple of housekeeping things to do before we do coding, okay? The first one is a code editor. A code editor is almost like a word processor, but instead of creating like documents you might use for business, the documents you're creating are computer programs. So a code editor is just a place to type in the instructions that are your program. The one we're all going to use today is at this link. Let me drop it into chat right here. Oh, good. There it is. Gracie dropped it in. Grab that link, and you're going to see a code editor. Don't do anything with it yet. Just open it up. And the next thing I want you to do is make sure you set it up so that you have your code editor that you just opened on the right-hand side of your screen and me on the left. That way, when I'm typing code, you can see exactly what I'm doing. You don't have to switch back and forth. So it would look like this. On the right-hand side would be your code editor. On the left-hand side would be the Zoom program where you're going to be able to see me and what I do. Now, if you have two monitors, this isn't a big deal. If you have one monitor, I want you to set them up side by side. Sometimes you need some help doing that. If you're trying to resize the Zoom window, sometimes if it isn't working, it helps to click on the word Zoom meeting and this little button called restore comes up. You can click on that. That can make it easier sometimes, okay? And then for the browser where the code editor is that you just opened up, there's a little button up in the top right, looks like two squares on top of each other. That can resize the window. So I'll give you all a minute to go and get that set up. And we're about ready to start coding. Now, the first thing I'm going to do is I'm going to show you the actual full game. I'm going to run the game, and then we're going to and play it for a minute. And then we're going to type a reduced version of that program. What we're really going to do is learn those 5 elements of a computer program, and we're going to learn how to do those in Python. And this will give you some of the fundamental skills of Python and the fundamental skills of computer programming, all like in the next hour. Okay? So let's switch here to, you're not going to get this until a little while. This is the full code for the game. Here's the code editor. On the left is where you put code, and on the right is a space for output. I'm pasting the code for the whole program. Now, don't worry about all this code. We're going to look through it in a bit more detail later on in the class. For right now, it might be a bit confusing if you've never programmed. But this is a computer program, and this is a computer program that lets you play Connect 4. So let's run the program. There's this little symbol right here. Looks like a triangle. I'm going to run the program. And you can see we've simulated a Connect 4 game. Now, if you're not familiar with Connect 4, when you have a physical Connect 4 thing, it's just like a big wall with slots. And you can go to the top and drop like a round playing piece down into the slot, and it settles in. And 2 players try to connect 4 in a row, either straight across, up and down, or diagonally. That's how it's played. So I am actually incredibly good at this game, and my sister hates me for how good I am. So I'm going to try to play a game. So I went right here with my X, and the computer went right next to me. So I'm going to go right here and go on top of it. Okay. And I'm going to go with a 5 here. Oh, I think I might have a bug in my program. Fun. Try it again. I'll debug the game later. All right, so they went on top of me. I'm going to go 4. Okay, and oh, haha, I'm going to win the game. Let me go with 2, and I'm guaranteed to win. 5, and now I have 4 in a row. Okay, good. So that's the game, okay? Now, all right. I'm going to erase all of this again, and we're going to go back to where you were before. And we're going to start writing some code. Later on, like I said, you'll get a full copy of that program's code. You'll be able to play the game. We'll look at it in a bit more detail. But let's start with something a little easier to kind of think with, okay? So, first of all, don't worry about what any of this stuff is. We can erase all of this. I want everybody to erase all their code, okay? But we're going to start with a very simple instruction. And even though it's going to be simple, there's a lot to learn just from this one instruction. All I want to do is cause something to be printed over on the right-hand side. The instruction in Python to do that is called print. So type print, and then an open and close parentheses. You may notice that this code editor completes the closing parenthesis for you. That's just a friendly feature of this editor. and I want you to do a double quote. It's just to the left of the enter key. Notice again that the code editor has a matching double quote, and we'll talk about why you need those in a moment. But now we need something that's going to display on the screen. So I'm going to go a little bit different. Go hi there from the right side of the screen. Yeah, let's do that. And go to the very end and put a semicolon. Now I'm going to explain all of this stuff. Okay. And now go to the top here. When you're certain, remember, type exactly what I typed. When you're certain you have it exactly the way I have it, go to the top here and press that triangle, the play button, and it'll run your program. And you see there, hi from the right side of the screen. All right, now, there's actually a lot going on with this instruction in terms of the fundamentals of Python and the fundamentals of how computers work. So we're actually going to take a couple minutes and examine this whole line of code, these instructions, in a little bit of detail. The first thing I want to talk about is this. Any computer programming language, and Python is no different, has a set of words that are built into it. They belong to the language. Those are the symbols and words and phrases that are part of the language. And in Python, the word print is one of those words. We call these keywords, by the way. Every programming language has its keywords. Those are words that you have to use in a specific way because they mean something very precise to the computer. In fact, that's what we're talking about. When you use a specific Python word or phrase or symbol, your computer knows exactly what to do when it receives that instruction because it's already been programmed into your computer. You can install Python on your computer, and from that point forward, when you're writing these instructions, if one of these instructions is Python, when you're writing this code, if one of the things in it is Python, your computer knows what to do. Now, let's examine that. I want to show you how your computer actually figures out what to do when you run the program. What happens is this. Your computer will start at the beginning of the line of code. And it'll start reading each character, one, and then the second one, and the third one, and it's doing something very specific. Here's what it's doing. It's going to read that first character, and it's going to try to figure out, is this character one of the built-in keywords for Python? Is this a Python instruction? It turns out that it's not. And the only other thing your computer can think with is, oh, well, is it a variable? Is this program using a variable called P? Well, it's certainly not. We haven't even created variables. We haven't even talked about how to create variables in Python. There aren't any variables in this program. So your computer goes, oh, all right, well, I got nothing I can do with this. It's just the letter P. I better go look at the P and the R. And it does the exact same thing. It says, is this a built-in instruction in Python? It's not. Is this a variable? No, there aren't any variables yet. And so on. Does that with PRI and then PRIN. But when it looks at PRINT, now things are different. Your computer looks at that collection of characters, that word, print, and goes, is this a Python instruction? Bingo. Yes, it is. And because it's already programmed into your computer what to do, your computer knows exactly what to do next. And here's what it does. Because it's been told to ahead of time because of how the print instruction works. Your computer is going to do something very simple and very precise. Your computer's going to go look at the very next character, and it better be an open parentheses. If it's not, it'll break your computer program. That's how this particular instruction called print was programmed to work. If you're going to use the print instruction, you need to give that instruction some information to do its job. And that information has to be contained within an open and closed parentheses. Here's another important part. The information inside the open and closed parentheses needs to be what's called text information. There's different kinds of information you can have in a computer program. You can have text information, numeric information, date information, and so on. So the way print works is it says, all right, I know what this instruction is. I know that I have to be given some text information, and I know that information has to be given to me inside of an open and closed parenthesis. And so this is what your computer does. As soon as it knows that it's dealing with the instruction print, it goes, okay, is the next character an open parentheses? It is, yes. Okay, good. All right, well, I need to go forward until I find another closed parenthesis, until I find a closed parentheses. So it looks through all these characters and it ignores them. It doesn't care because it's been told to go forward in this line until it finds a closed parentheses. It goes, okay, good, I found that. Now, I need to grab all the content in between these two parentheses. I need to make sure that it's text information. And it is, by the way, one of the things that's true in Python and frankly in almost every programming language is that you can indicate that information is text by putting it inside of these quote marks. So the your computer has one, figured out that it's dealing with an instruction called print that is a Python instruction. Two, figured out that the next character is in fact an open parentheses like it should be. Three, has found the matching closed parentheses. And four, has grabbed all of the information inside those closed parentheses. And then it's gone forward one more and saw this character, semicolon, which means that's it. That's the end of the instruction. Can you please do it now? And it says, oh, print the information inside these parentheses. Okay, I'll do that. Boom. And it does it. Now, I know I just took several minutes to describe what the computer does. Do you notice how fast it does it in real life? Run it again. It happens in less than a second, right? Because all those super small, one step at a time actions that I described, reading one character, and then two, and then three, and then four, and five, and then identifying that we're dealing with a Python instruction, and then looking for the right pattern of open parentheses and a matching closed parentheses, and then grabbing all the content inside of it and making sure it's text information. Your computer does that in a couple of milliseconds. It's super fast at doing all that. But that's actually what it does. So, a couple of high-level things to walk away with from this one line of code. One, computers only do one thing at a time. One step at a time. Two, computers can only ever do something that's been programmed into them ahead of time on what to do. If a computer is ever given an instruction that it has not been told what to do for that instruction, the program just stops. Computers can't figure out what you meant or figure out what the most logical thing to do is. They're machines. They don't think. The third big takeaway is this, for Python at least. If there's an instruction, and print is an instruction here. Where's my print is an instruction. If there's an instruction and that instruction needs information in order to do its job, that information is contained inside of parentheses. In fact, the terminology we use is that the information is passed into the instruction. Whatever's inside these parentheses is passed into the print instruction so the print instruction can do its job. All right, now I know that was a lot with one line of code, but there is a fair bit going on here. All right, now let's go on to, we have a first line of code. We can tell that it's, the first thing that gets executed. Let's see if we can use some variables. I want you to skip a line, and I'll explain something. The skipping a line doesn't do anything in terms of how your program works. It just makes it easier to read your code. All right, so we're going to make a variable. In Python, there's another built-in instruction, one of these keywords called let. Oh, wait, no, that's wrong. I program lots of programming languages. When you make a variable in Python, all you need to do is come up with a name for the variable to begin with. And let me explain this in a bit more, like a little more strongly. Remember how I said that variables are all about keeping track of data that can change while your program runs? Well, let's think about where that data is stored. Where do we keep that information? We keep it in those memory devices, that RAM. They're physical devices, they're 3 or 4 inches long, and you can kind of think of one of these devices as a giant collection of individual, unique locations where a piece of data can be stored. You can almost think of it as a bucket, except that there's sometimes 3 or 4 billion buckets on one of these little devices. It's pretty amazing. But the points here are that, one, they are unique locations, and two, that you can store information inside each location. So what we do when we make a variable is we are choosing one of those locations on the memory device where we're going to store some information. But we need to give that location a unique name so we can refer to it later on. That's called the name of our variable. Let's make one. Again, we're going to use the idea that we're playing a Connect 4 game, and let's say that we want to figure out, we want to display the name of the player. So we're going to have a variable called player1. That's the name of our variable. Variables cannot have spaces in them. They need to be all one consecutive series of letters or numbers. So that's a variable. Now hit a space and the equal symbol and a space, and give yourself some double quotes and type in your name and then a semicolon. Now, let me explain a bit more about what's going on here, because again, it's a relatively straightforward instruction, and many of you have probably already figured out in principle what it's doing, but I also want to give you some of the terminology involved. The first thing that's happening at the beginning of this instruction is when the computer sees this word player1, it knows this is not a Python instruction. So the only other thing it can be is a variable name. And because we've never used this variable name yet in our program, the computer does something very specific. It's called initializing the variable. And specifically, what the computer does is it goes into the memory device, like the RAM inside your computer. It finds a single location inside that memory device, an actual physical location where data can be stored, and it gives that location a name. It doesn't put any information in there. There's no data at that location yet, but that location has a name. And that's called declaring a variable. And then this symbol is called an assignment operator. This tells the computer, hey, you know that variable on the left of me? Good. Whatever information is on the right of me, I want you to put it in that location of the variable. Now, if you think of our analogy of buckets, we've put a name on the outside of the bucket called player 1, but inside the bucket, we've put the word Erik, or whatever you chose. So again, the two pieces of terminology are, here we are declaring the variable, and here we are assigning the variable a value. And the cool thing is, if we ever want to use this word Erik, all we have to do is actually use player 1, and we can get the value inside of it. We're going to do that right now. So hit enter again, and let's do another print, P-R-I-N-T, and we're going to type in here, quote, current player, colon, space. I'll wait for all to get caught up. And now this part's really important. Move to the right so the cursor's in between the double quote and the end parentheses. Hit a space and then the plus symbol and then our variable, player 1. Type it exactly the way I typed it. And go to the end, put a parentheses. Now we're going to run this and I'm going to explain it. Go ahead and run it when you're ready. Now, we already know the instruction print. We also know that print needs to be given some information in order to do its job. And that information is going to be inside of our open close parentheses. But in this case, the information is a little weird. Part of it is what we call text data. We also call this a string. It's like a string of letters and numbers, okay? So here we have some text data, but then we also have this weird symbol for plus, and then we have the name of our variable, player 1. So let's talk about what's happening here from the inside out. We're going to start right here with this symbol. This is not a math symbol right now. The computer is able to determine that because we need text information to be inside these parentheses, that this symbol refers to something the computer can do with text information, not with numbers. Specifically, what this symbol does is it takes one piece of text and just connects it to a second piece of text. We call that process concatenation. Big old fancy word, concatenation. It just means sticking two pieces of text together to make one piece of text. That's all it means. But what's kind of cool is that this symbol, this plus symbol, that we're all so used to seeing when we do math, doesn't refer to math here. It refers to joining together two pieces of text data. Well, this piece of text data, is pretty straightforward. We typed it out. It's inside of double quotes. We know it's text. But what are we doing here? Well, when you run it, notice it doesn't say current player, player 1. What the computer does is when it reaches this, it goes, oh, that's the name of that variable, player 1. Let me go get the data stored in that variable. In this case, the data stored in the variable player 1 is this text information right here. Now, we're going to write another line of code, but I do not want you to run your code, run your program afterwards. I'm going to ask a question first. So go down here and we're going to make one more change. Let's say that the player changed their name. Let's go player 1 equals Doug. Don't run your code. I'd like you to take a guess in chat. When we run this, what's going to be printed over on the right-hand side of the screen? What's the last thing at the bottom that will be printed when we run this code? Put your guesses inside a chat. Got some Doug, got some Eric. Well, or whatever your first name is, right? On mine, Doug, Eric. Okay, good. Most people are saying Eric. Now, the correct answer is Eric. Let's go and run it. Or whatever your first name is that you put here, okay? Go ahead and run it. Now, why didn't it say Doug? Why didn't it say current player Doug? The value of player 1 has been changed to Doug. Now, this is super important. When you start a program, it starts with the first instruction, and your computer knows nothing about what is later in the program. It literally hasn't looked there yet. The computer has no idea even that there's an empty line here, because it hasn't looked, and it won't until it's done running this instruction. Only then will it look here and go, oh, there's nothing there. Let me look here. Oh, I'm going to make a variable called player1 and assign it the value of Eric. Okay, I'm done with that. Now, oh, I'm going to print current player, and then I'm going to use the current, this is the important part, the present value of the variable player1, and that value is Eric. It's not Doug yet. And only when it's done doing that, which is when we get this output, only when it's done doing that does the computer go, oh, we're going to change the data inside of the variable called player1. And that's why it doesn't print. Now, the cool thing is we can make use of that. Let's print it again. Let's print current player, colon space, and do that plus player1. It's the exact same thing we have right above. And now run your code. And here's the important part. I'll wait until everybody's done there. Remember when I talked about the 5 fundamental elements of any computer program? And I said that variables are used to keep track of data that could change while your program is running. Well, that's exactly what we did here. At this point in the program's running, they call it the execution of the program. At this point, in the execution of the program, the value of the variable player1 is Eric. But then we changed it, and more importantly, we were able to make use of the now changed data. So again, I know it's a simple example. We're changing the name of the player, but the principle is the most important thing. Variables keep track of information that could change while your computer program runs. All right, now, I'm going to teach you one other thing here. Let's go up here where there's this empty line. And I want you to type this hash mark. It's just above the 3 on your keyboard. And then type variables. Well, you might want to spell variables right. Let me explain what this line is all about. It's called a comment. Comments are not instructions to the computer. When the computer sees that hash mark symbol, it goes, oh, I could ignore anything after this on this line of code, because it's not actually code. It's just a comment. But they're very helpful to us as human beings. You can leave comments that explain why you built something a certain way inside your code. And then that's helpful to everyone. It's helpful to anyone who has to work on the program you made. But it can also be helpful to you if you return to your program like 6 months later and you don't remember why you built something a certain way. If you left good comments, you'll be very happy with your past self. All that said, let's go down here and we'll do another comment. Go to the very end. And we're going to work on control and branching. Nice little comment there. And test it. Go ahead and run the program and notice it doesn't change anything. It works the exact same way, right? Now, remember I told you control and branching is all about making it so your computer program can make a decision. So let's just talk through this before we write any code. I want my computer program to be able to take a look at, like for a given player, how many tiles they have in a row, 1 or 2 or 3 or 4. And if it's 4, then we can tell the player that they won the game. If it's anything less than 4, we're going to tell the player something like, sorry, keep on going. We need the ability to tell the computer what to do in those 2 different cases, because it's going to be completely different, isn't it? If the player has not yet won the game, then we're going to turn it over and let the other player, the computer, take a turn. But if the player does win the game, we're probably going to pop up a nice message and then ask them if they want to play again. That is a perfect situation for control and branching. We need the computer program to make a decision. But first we need to give it some information in order to make the decision. So let's make a variable called in underscore, let me get back over here and type. In underscore, and the underscore is like the minus key, but you do shift. A underscore row, space. That's the name of our variable. Actually, let's make it a little clearer. And I'm going to go underscore 1. So this is for player 1. How many tiles does player 1 have in a row? That's the data that will be stored in this variable. Let's start out, and it's 0. Well, actually, it's 1 because they just dropped their first piece. Now, this is actually a pretty important thing. Pretend we were playing the game, and I got to take the first turn, and I dropped 1 tile onto the board for this game Connect 4. You and I, visually looking at the board and knowing that we just started, we are absolutely certain that I don't have 4 in a row, right? But your computer can't see. Your computer has to be told exactly how many are in a row, and then using that information, decide whether to let the person keep on playing, or if they won, give them a nice message that they won. So what we're going to do is write the code that can make that decision. So go ahead and hit enter. And this is the control and branching. There's a control instruction called if. Type if, and then give me an open and close parentheses, and go to the end of it, and give me a colon. Now, we're going to type all this out, and then I'll explain the structure of what we have. Hit enter. You'll notice that your cursor suddenly got moved over 2 spaces. The code editor did that, and I'll explain why in a moment. And then I want you to type print and leave it empty. Go to the end. I'll go slow here for a second. Hit enter, but now hit backspace to go back to the beginning of the line and type else and a colon. Hit enter, and notice, I'll tell you why in a moment, your cursor went over 2 spaces. Type print All right, now let me explain everything we're looking at. Yes, for those of you who've programmed before, I have left some things out, but I've done it on purpose. The whole concept that I talked about at the beginning of the class, and that we even wrote right here, is it's got two parts: control and branching. Control instructions are the instructions you use to tell the program to make a decision. And the specific decision is something true or false? That's the decision. It's the only decision a computer can make. A computer can't decide that something's mostly true or mostly false. A computer can't decide that something's good or bad or happy or ugly or joyful. It can only decide, here's some data. I'll explain that in a second, Diana. It can only decide, is something true or false. That's all it can decide. And that's what control instructions are all about. If is a control instruction. Now, we're going to put something inside these parentheses. We're not going to write it yet, but it will be something that is absolutely either true or false. So let me explain in plain English the way to read these 4 lines of code. The way you read it is, if the condition inside the parentheses is true, then do this branch of code right here. Otherwise, do this branch of code. I'll say that again. If the condition inside these parentheses, and I know it's not there yet, we're going to make it. If the condition inside these parentheses is true, then do this branch of code. Otherwise, do this branch. That's how to read this. And it's exactly how the computer interprets it. So, again, before we put the condition in here, I want to explain what is up with this colon and this colon. If you use a colon at the end of a line, it lets you create the branches down below. After the colon, any line that is indented is part of a branch that's only going to be executed under specific conditions. In other words, we're only going to do this instruction right here if our condition inside here is true. But how does the computer know when it's done doing the things it's supposed to do if the condition is true? Well, if the instruction is no longer indented. Thanks, Irina. Same thing with this. This is our second control instruction, and it has its own branch. If you put a colon here, then everything underneath it that's indented is part of the branch. If it's not indented, it's not part of the branch. This will become a little more clear when we fill the rest of this in. Let's go ahead and put our condition in here. What we're going to do is check if the current value of in a row is equal to 4. So you type the name of your variable, in underscore a underscore row underscore 1, and then space, and do 2 equals, and then the number 4. Now I'll explain everything that's going on in here. Grab a sip of water. So we already know what in a row is. It's a variable. We declared it over here on line 8. We assigned it a value of 1. So we know what in a row is. We clearly know what the number 4 is. What's this? These 2 equal signs side by side are a special instruction in Python. We already discovered that this is called an assignment operator. And it says, take whatever's on the right as a value and assign it to the variable on the left. This is an assignment operator. It assigns values to variables. This is a comparison operator. It compares the two pieces of data on either side of it. And it decides whether or not the two pieces of data on either side are equal to each other. That's it. It compares the two. And it's pretty cut and dry. Either they are equal to each other or they're not. There's no ish. There's no, it's kind of close. It's very simple, and it's the way computers operate. It's either yes or no, true or false. That's it. There's no maybe. So we know that right now, when we're running this program, if we were to run it right now, when we get to this if statement, the value of in a row is 1. So it's not equal to 4. So we're not going to do this branch of code. Instead, we're going to do this one. Let's test it by putting something kind of cool in here. If in a row is not equal to 4, that means they have to keep on playing. So good move, keep playing. There we go. That's what we'll print. Oh, this is supposed to be a semicolon. Diana, I see what you were talking about. Good catch. All right, so I changed the end of line 12 to a semicolon. I made it as a colon. That was totally my mistake. Remember, the semicolon just says to the computer, this is the end of the instruction. Please perform it now. The colon says, below this line will be indented the instructions in a specific branch. It means two different things. All right, so let's go ahead and run this program. And you should get good move, keep playing. Why do you get that? Because when the computer got to this if statement, the value of in a row was equal to 1. So we did not do this branch of code. We went to the else and we did this branch of code. Now, what are we going to do if it does equal 4? I want to be really positive. So go here into the first branch and type, you win. You are amazing. All right, run the program again, make sure it works. And it still says good move, keep playing. As it should. Now, watch this next part very carefully and don't run the code until I tell you to. Go to the end of your program, hit enter. Notice we're still indented. We don't have anything else we want in this branch of code under the else. So hit backspace, go back to the beginning of the line. In fact, you can even hit enter to make it a little more readable. And I want you to pretend that all of a sudden our player 1 does in fact have 4 in a row. So type in a row underscore 1 is equal to 4. Don't run the code. What's the last thing that's going to be printed over on the right-hand side? Put your guesses in chat. When we run this, what's the last thing to be printed over on the right-hand side? That's correct, Ernesto. Good job, Cliff. Go ahead and run the program. It is, in fact, good move, keep playing. Because like we talked about before, we didn't change the value of the variable called in a row 1 until after we had already run this control and branching code. All right, now let's talk about one last kind of cool thing here. This little sequence right here of determining whether or not the player has won the game, we have to do that every single turn they make. And I've done the math on it. I think you can have, an individual player can have up to 25 turns in a game. I don't know about you. I don't want to write this code 25 times in my program. So I'm going to make a subprogram. I'm going to take this logic inside here. The logic of look at the current number of tiles or playing pieces in a row that the player has and determine whether or not it's 4. And do one thing if it's 4, another thing if it isn't. That logic, I need to be able to call on that logic over and over and over and over again as the player plays the game, but I don't want to have to type out these 4 lines of code. So we're going to make what's called a subprogram. Go and hit enter, go to the very bottom. In Python, we call these subprogram things the functions. We call them functions. And you make one first with a special Python instruction called def. It stands for define. We are defining a function. So type def and a space. But now we need a name for our function. Let's call it check underscore win. We're checking whether the player won, right? Now, we need to give this function some information. We need to give it how many in a row. When it's given information, that's what the information represents. Every time we ask for this function to be performed, we have to give it, at that moment in time, how many pieces does the player have in a row? And we're going to use that, we're going to store that in a variable, and we're going to call that variable how many in a row. Now make sure you've typed exactly what I have. And now we're going to lay out the actual instructions inside our subprogram. Pardon me, inside our subprogram. Remember, we call them functions, not subprograms in Python. It has a lot of different names. Depending on the computer programming language, it might be called subprogram or function or method or subroutine. There's lots of different terms. It's all the same concept. What we're going to do is lay out inside of this, do a colon, okay? Inside of this function, we're going to lay out the answer to the following. This part's super important. Don't type anything. Just listen. This is a very important concept. What we're about to lay out on the lines below this are the exact instructions that will be performed if and only if this function that we're creating ever is asked to be performed. It's really important. We're defining potential action that could happen. We're not asking it to happen yet. We're just saying, if you want this behavior in the future, here's what the behavior is going to be. We're going to call the behavior check win. We're going to give that behavior the current number of pieces that a player has in a row. And then it's going to do the following. Go ahead and go to the end. Make sure you have your colon. Hit enter. Notice we indented a little bit because we're about to define a chunk of code that's only going to happen in a specific situation. It's only going to happen if later on in our program, we ask for the check win function to be performed. So the first thing we're going to do is we're going to check whether or not the value of this variable, how many in a row, we're going to check whether or not the value of that variable is equal to 4. We've done that before. Do an if, and then type the name of the variable, how many in a row, space, double equals for the comparison operator, and then 4. We're checking whether or not that the value of that variable is equal to 4. Do a colon. What are we going to do if it is equal to 4? Hit enter. Notice we indent again because this is the branch. If is the control instruction, and now we need the branch that will be done if how many in a row is equal to 4. Well, we're going to print you win the game. That's it. I don't want anything fancy. You win the game. Put a semicolon at the end of that. Okay, fine. What are we going to do if it isn't equal to 4? We'll hit enter. Now this part's important. Backspace once so that you're at the same level as the if statement. And now give us the else with a colon. Hit enter. And what are we going to do if it's not equal to 4? We're going to print not enough, keep playing. I like that. And then put a semicolon. All right, now, again, nobody run their code. I want you to put your guesses into chat. What is the last thing that's going to be printed on the screen on the right? If we run our code, what's going to be printed on the right-hand side? Put your guesses into the program. That's correct, Cliff. Good job, Ernesto. Yep, great, Jake. You all have the right guess, which is go ahead and run it. Good move, keep playing. Most classes, I get someone that guesses that it would say, not enough, keep playing. Why doesn't it? Because this is the definition. We've defined a function. We've said if and only if we call upon this function to be performed, will you then do what's inside of it? We have not yet called on it to be performed. So let's do that. Go to the very bottom of the screen there, hit enter, and now make sure you backspace all the way to the beginning and hit enter. We're done with that function. The function is called check win. But now, let's say I have a player called Erik. And Erik, his score is 1. He has 1 in a row. Erik's got 1 in a row. Make sense? And now I want to check whether or not Erik won the game. I can call the check underscore win function and in parentheses passing the value of Erik. Now, when we run it, not enough, keep playing will come up as the final instruction. Why? Because on this final line of code right here, I've called the check win function and I've passed in, this is important, the value of the variable Erik. What's the value? Right now it's 1. So now we call the check win function and we pass in the value 1. So now this variable, how many in a row, is assigned a value of 1. So when we check if how many in a row is equal to 4, no, it's not. It's equal to 1. So we don't do this branch. Instead, we do this branch. But now let's go to the bottom, and let's say that Erik magically got 4 in a row. Now let's run check win and pass in the value of Erik. I'll let you get caught up. Run your code, and you win the game. Now let's make it even a little more cool. Let's say that we want it to print off the person's name. I have player 1 up here, right? I can go to my function and I can say I'm going to give it two pieces of information. How many in a row, and also name. And then I can go in here and print you win the game, do a space, and then use that concatenation, and it'll print their name if they win. I think that's awesome. So now when I pass in, let's see. Oh, I changed player 1 to Erik. I want to keep it Erik. So change it back to Erik or your first name. Make sure player 1 is your first name, okay? And go here, and when we call check win, we're going to pass it both Erik's score and player 1's name. Same thing down here. When we call check win, we're going to pass in the current score for Erik and the name for player 1. Let's run that. And it says, you win the game, Erik. And those are subprograms or functions. Notice what's cool here. This logic that we communicated in 4 lines of code here. We figured out how to determine whether or not a player had won the game, but it took us 4 lines of code to do it. But after we put those 4 lines, that logic, inside of a function, now it takes us 1 line of code to check whether or not a player has won. 1 line of code. And notice if I want to change the message, I could go here and change it to an exclamation, and that change is reflected everywhere that I'm using the function check win. So there's so much advantage to learning how to make these subprograms or functions, whatever you're going to call them. It's a really powerful element in any computer program. All right, now I want you to see the full game. Can you do me a favor, Gracie? Go ahead and drop the link to the full code inside chat. There we go. Everybody now has access to what I'm showing you right now. Copy all of that like a Control A and a Control C, or Command A, Command C on your Mac. Go back to your editor, select everything and delete it, and then paste in that code. Diana, are you getting an error with what I'm showing you right now or on your previous code? Okay. Yeah, I can't. I unfortunately don't have the time to be able to debug exactly what was going on with that. It probably had to do with when we added in name as a variable to that function. I shouldn't have added that complexity in, but it's kind of fun. But you'll see some examples of that like in here. Okay, so once you've copied the code in here, go ahead and run the program, and you can play the game yourself. I'm going to give everybody a minute to play the game. Try and win. It's a fun game. Come on. I'm taking up too much time. Okay, so there's the game. Let's look at some of the logic in here, okay? Now, we're not going to go through every single line of this program. There's way too much. We'd be here a couple of hours defining terms, but I want to show you that the same building blocks are there. First thing is there's this Python instruction called import This means if someone else made a program that's of value to me, I want to bring that program into mine. And in this case, someone created a program called random, which helps you generate random numbers. And since I don't want to have to deal with the logic of making random numbers, I'm just going to bring that in or import that program. But then notice we have DEF defined. So we're making a function called initialize board. Notice that it takes two variables. Here's another function called print board. Another function called drop a piece or drop piece. Another function called check win. That's pretty comparable to what we were doing, right? And then there's a function called computer move. Simulate a computer move, okay. And there's a function called main. Now this part's really important. Anybody notice this? Was kind of interesting. When the computer starts reading this file, reading this program, it's not doing anything yet. It's not doing any work. Look at this. We are bringing in another program called random. Okay, we haven't done anything yet. We're defining a function. Well, that doesn't do anything unless we call on that function. We defined another function, print board. Defined another function. Defined another function. Defined another function. We haven't done any work. There's a real important point here. We need to find the first point in this program where we actually do something. If we go down, you'll see that it's right here when we call the function called main. It's at the very end. Now, if you were trying to understand this program, it'd be kind of easy to you kind of maybe understand it if you start at the top. Initialize the board, okay. But it's going to be so much better if you can follow along with what the computer is actually going to do. When you run this program, the computer, the first thing it actually does is it runs the main function, which is right here. And the first thing it does is make two variables, rows and columns, and then it calls initialize board. Oh, and it's going to pass in 6 and 7 because that's what we have. Oh, we're going to call initialize board 6 and 7. Let's go to initialize board. Where is it? Oh, up here. So we're passing in 6 and 7. And I might need some help to understand this part, but it sure looks like what I'm creating is a grid. I'm creating some columns and some rows. You can follow along a little bit. I know there's a lot more here if you've never programmed. You'll be like, Eric, I'm not sure what all this is. But it's still the same basic building blocks. It's subprograms. It's variables, right? Where's our variable? Here's variables. It's control and branching statements. Look at that. We get some if right here. It's subprograms. Here's a subprogram. It's all those basic building blocks is how you make a program. All right. So let me look at chat. Okay, good. Anybody, I'm going to a little bit of Q&A thing here. So who's got questions? Drop them into chat and then we'll move on. I got your free gift coming in a second. Okay, I'm watching the chat. So if you think of something while we're going through the rest of this, drop it into the chat. I'll do what I can to help. All right. So let me tell you a bit about our who we are and what we offer. We have 12 online coding boot camps, and they cover a wide range of technology subjects. You can see it's everything from artificial intelligence, which is kind of popular right now, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. I'll get to your question in a second, Ernesto. In fact, we have more certification programs than any other coding bootcamp on earth. Okay. Um, and what's more important is how those programs, how our boot camps are delivered. They're self-paced, but also instructor supported. They're flexible. Students set their own schedule and they can enroll any day of the year. The content on each of the boot camps is well-rounded and in-depth. They're affordable, priced under the national average. Every single one of these boot camp programs includes job placement training and job placement assistance. But most importantly, they're designed for absolute beginners. No technology knowledge or experience is required to get through our boot camps, so you don't have to be a nerd. And who are our programs for? Anyone looking for a better career. Tech's a great industry to work in. There's remote work opportunities. It allows for better work-life balance. It pays well, a lot more. Okay. Let's see. Ernesto asked, do you have a favorite Python programming environment? I do almost all of my programming now inside of Visual Studio Code. I know there's another editor called PyCharm, which I've used in the past, and it's fine. I just like Visual Studio Code because I can do almost any programming I need to inside it. I love it. And then Mike asks, how can I learn to understand the structure of a templated website? The first part is to learn the fundamentals of HTML, which means hypertext markup language. That's the language you use to write websites. Learn the actual fundamentals of it and the fundamentals of CSS, which means cascading style sheets. It's the language we use to style websites. Learn those two things well. And finally, learn a little bit of JavaScript because we use JavaScript in those templated websites. If you know those three things, even on a fundamental level, now it'll start to become obvious to you why the structure is the way it is in the templated websites. So that's it. I mean, it's unfortunately, without digging deep with you on a one-on-one mic, that's the best answer I can give you. All right. So another real cool thing we're happy with is that we consistently land on every single major best coding bootcamp list. And in fact, this last February, just a few months ago, Newsweek came out with their annual top boot camps in the world list. They ranked 31 boot camps in the whole world, and we were on that list. And there's thousands of boot camps around the world. So we're really proud of that. Our average review rating across all major bootcamp review sites is 4.8 out of 5 stars. That's based on student and graduate feedback. And so obviously, those are the people you want to listen to. Don't listen to me, listen to people who've gone through the program. Okay. Now, I do want to address one thing. Why might you consider working in tech? A couple high-level things. It has really good work-life balance. I've been working in technology for decades, and I know many, many, many technology workers. We rarely work more than 40 hours a week. It's actually extremely rare that happens. Okay. There's also remote work possibilities, especially even more after COVID, right? And it's a really creative industry. You get to solve really cool, challenging problems in creative ways with really smart people, and you can take a lot of personal pride in your work. It's also a stable industry that pays well. And as you keep learning and building your skill set, you can get regular increases in pay. It's actually kind of wild. The average salary in America as of last year was about $59,000 a year. That's the average salary across all economic sectors. The average salary for a software developer was $120,000 a year. Literally twice as much as the average. So no matter where you get into the industry, which bootcamp, which route, which specialization, what kind of company, you're going to make more than you would in most other places, which is kind of cool. Now that said, there are barriers to doing a bootcamp. We know this, okay? One of them is money. It costs thousands of dollars to do a bootcamp. And we've tried to make that as easy as possible by offering many different financing options, including a huge upfront discount if you can pay for the whole thing up front, or if you need to do it monthly, we have different programs for people with any kind of credit situation. But I will put forward that I really do consider getting through one of our boot camps an investment in yourself. You're giving yourself a set of skills that are super valuable and that many people either don't want to learn or feel like they can't. And that puts you in a powerful position to have those skills. The next barrier to getting through a boot camp is, quite frankly, time. There's a lot to learn in a short amount of time if it's going to work, right? Some boot camps try to solve this by organizing their training into groups of students called a cohort. And all the students start on the same day. And they move through the curriculum at the exact same pace. And I hate it. I can't think of a worse way to learn technology because none of us learns at the same pace. In fact, some boot camps even make you attend in person so they can try to control the whole situation. What we've solved is actually pretty wild and pretty amazing. Our programs are fully online and they truly are self-paced, which means you can choose your own study schedule and still get through the program. You can do part-time study. You can fit it in around a job, or if you're going to college, whatever you're doing, you can fit it in around your schedule. The last barrier to getting, through a boot camp is that there's got to be some level of technical interest and ability. Now, in terms of interest, look, it's a Friday night, and you all took time out of your lives to attend a free coding class. There's probably some interest there. It's the point of technical ability that I want to mention one small thing on. All too often, when I'm talking to people who are thinking about breaking into technology, they want to be a programmer, they want to work in tech, they've got friends that do it or whatever, they'll tell me, I started studying it, but I started to feel stupid. Or like maybe it was too complex, or I just couldn't quite grasp it. And I want to assure you of something very simple. It's not you, it's the training materials. A lot of technology education materials are too hard for one very specific reason. The people that make the materials assume too much prior knowledge on the part of the student. They've forgotten what it was like to be a beginner, to not really know the subject, and so they'll assume you already know things and they'll skip over them entirely and you just get lost. I've done it myself years ago in creating some of the first curriculum. And it got called to my attention. It was tremendously embarrassing, and I vowed never to do that again. So all of our programs are built so you don't have to have any prior knowledge. You don't have to be a nerd. You don't have to have any technology background. Now, just a quick question. Are you perhaps working in a dead-end job or a job where the maximum amount of money you could ever make, even if you stayed in it for years and got really good, is just not high enough? Or maybe you're even unemployed, or you want a job that could let you work from home, but the career you're in literally can't be done from home, or the employers would never allow it. Or maybe you just want more time with your loved ones. All this is to say, is it time for a career change? And if the answer is yes, the Tech Academy is the solution. We are career change experts. We chose that orange bridge that you see in our logo on purpose. We tried to create a bridge or a route into technology for everyone. And at this point, we have well over a decade of experience breaking people into tech, and it works. Most of our graduates earn $30 an hour on average in their first job. That's the equivalent of $60,000 a year. Obviously, it varies depending upon who you are and where you get hired, but it's been 11 years, more than 11 years, and that average still remains strong. $30 an hour is where people start, and they move up from there. And it's a lot of people. We have thousands of graduates now working in tech, and anywhere from small businesses, medium size, and even the huge companies like Epic Games or Nike or Facebook or Uber or Disney. We have people everywhere. So as a reminder, we have open enrollment. You can start anytime, okay? Patrick, no, but there are lots of other things that can help, okay? Dude, Brian, you just broke my brain. One of our students just said, my prior knowledge. I learned Fortran. It's a programming language. It means formula translation. It was developed in about 1958 to 1961, and he used it all the way up until as late as 1992. Dude, mad props, Brian. That is fantastic. Never learned Fortran, and I'm kind of glad I didn't. I did learn machine language and basic and a bunch of other stuff. Anyway, sorry about all the gobbledygook. That blew my mind. So I encourage you to enroll now. You can enroll anytime. And we have, is it the 11th? Yeah, okay. Yeah, it's still the month. So if you enroll in April, there's some very cool things we can do for you. First of all, if you can pay up front, you get a full 50% off. 50% off of tuition. It's a huge discount. It can save you potentially $5, $6, $10,000 if you can pay up front. Also, if you pay up front and you live in America, we can send you your own laptop to do your training on if you need a laptop. Also, if you enroll in April, you're not going to pay any sales tax no matter where you live. We'll pay it for you. That can save hundreds or thousands of dollars depending upon where you live. Okay. We'll also ship you our coding books, including the Intro to Coding book that we have. We have several of them, right? Our Computers and Technology Simplified book and our dictionary. The Technology Basics Dictionary is awesome. Simple definitions for thousands of technical terms. Also, if you enroll in April, you'll get a career planning guide. Now, this thing is very special. My co-founder, Jack Stanton, and I made this. I was just looking at it the other day. I've got a copy on my shelf. It's what I wish I had to plan the first 3 years of my career. It lays everything out. What do you do during the first 6 months, the first 18 months, the first 36 months? What do I focus on? What can I ignore for now? How do I decide on a focus? All of these things are answered. It's a valuable book, and we give you a free copy if you enroll in April. Okay. You also get 3 months of free access to what's called the Tech Academy Accelerator, which is one of my favorite things in the world to deliver. This is a subscription offering, which first of all gets you access to over 100, actually at this point almost 200 educational videos. And the big thing is every single week on Tuesday, we have our accelerator workshops, which are super deep dive, open voice, open chat, open camera. It's a conversation. We build things, we break things. You see what it's really like to do technology. We call it the accelerator because it'll really help accelerate your career. And you get 3 months of free access to that. And finally, if you enroll in April, you'll get unlimited job placement assistance, which means once you're done with your boot camp and you work with our job placement personnel, you can work with them literally for as long as it takes for you to land your first job. Doesn't matter how long it takes. Okay. It happens fast for a lot of people, but that way you have some certainty there. All right. So this is how to find out more. And by the way, stick around for your free gift. We're seconds away from it, right? There's a link that Gracie just dropped into chat. If you're interested in finding out more about the school, then go to that link, fill out the simple form. It's like three different fields. And what follows that form is a series of really cool steps all about the school. There's videos and articles and such that explain what's on every single boot camp. What order are the courses in? Why are they in that order? What does the job placement assistance look like? What does the live project look like where I'm actually part of a software development team? Every single question you could have is answered in those videos and articles. So just go to that link, fill in that form, and you can learn a lot. I'm going to take a sip of water real quick before we move on. Fortran. Wow, I'm impressed, Brian. That's awesome. All right, this is worth mentioning is our referral program. Since our graduates love us, referrals from students and graduates have long been one of our top enrollment sources. And so long ago, we put in place a referral program where we pay a 5% commission payment for any enrollments that come from a referral. And that's not just for our students and graduates. You can do that too. So in a moment, we're going to give you an email address that you can email into to get your free gift. If you've got someone you want to refer to us, you can include that information in the email. We keep track of that. And if they sign up, we will, in fact, send you a 5% commission payment. I mentioned books. We have 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, the Technology Basics Dictionary I talked about, the Project Management Handbook, and You Are Not Stupid, Computers and Technology Simplified, which is an amazing book. At the very least, if you have your family read this, you will stop being the technical support person for your family, which is cool. And here's our free gift. It is our Introduction to Python book. This book is awesome. It's been fully revised as of 2024. We wrote this about 10 years ago. Fully revised as of 2024. And this, you can learn so much from this book. You know those 5 elements the 5 fundamental elements of a computer program. We expand on that in great detail. We cover all the syntax and rules of Python. You go through the exercises and you build all kinds of code and programs. This book rocks, okay? And you can get a free copy sent to you. There's an email address that's going to drop into chat. Gracie, can you drop that in? Awesome. So if you want a copy of this book sent to you, send an email to books@learncodinganywhere.com and let us know, I was on the class with Erik about Python. He said we could get a free Python book. Here's my address. Please send it. And we will, in fact, send it out right away. Our folks are really awesome about that at the office. Okay. And also, if you have any other questions for us or if you have any referrals, you can include that information in the email. But I'll give a second for people to send an email if they want to. And don't forget your mailing address. Every so often we get an email that says, yes, I'd like the book, but they don't give us an address to send it to. And by the way, this is for the US only. I'm sorry we can't send these overseas. All right. Now, I mentioned links, like links to this recording and all that kind of stuff. There's a link that just got dropped into chat, and it takes us to our link tree. If you're not familiar with Linktree, it's just a single page that has all the links for a business. And you can find everything there: our social media, our books in our dictionary, upcoming meetups, free educational YouTube video list, all of it. Links to everything is on there. Okay. So anything about the school, you can find there. Follow us on social media. Please check out the YouTube list. If you're interested in technology, there's so many cool free resources on our YouTube channel. And that's what we have. Thank you so much for attending. Super appreciate it. Check out Meetup. And if you're at all interested in the school, it's worth checking out. Like, it can change your life. Technology is a phenomenal industry to be part of. You're welcome, Ernesto. Thank you so much. All right. So that's what we have. Have a great evening, and I'll see you soon.